Hi there, in this video we're going to build a CRUD API using the FastAPI framework in Python. What we're going to do is build an API for music tracks that will allow users to retrieve information with GET requests. It will allow them to send new information to the server with POST and PUT requests, and it will also allow them to delete tracks from the API with delete requests. Now those are the four most common HTTP request methods: GET, POST, PUT and delete. There are others and I will leave this Mozilla link in the description, but for this tutorial we're going to work with those four and we're going to use FastAPI to do so. The starter code is available here on GitHub. I will link this in the description, and we currently have that in Visual Studio Code. So if we go to VS Code, important to note here, there's a data folder with a tracks.json file, and that file contains some JSON data that we're going to use, and in this tutorial we're just going to load that into memory and create a CRUD API based on that data. In the next video we're going to use the SQL model package and we're going to create a relational database, which is a bit more realistic. But for this video we want to focus on the core concepts of FastAPI itself. There's a requirements.txt file here, and you can install those requirements with this command at the bottom here, pip install -r requirements.txt. Now let's investigate the structure of this project. We have an init.py file and we have two empty Python files, main.py and models.py. The models.py file is going to hold Pydantic models that represent the structure of our data, and the main.py file will contain our FastAPI application. Now the first thing that we're going to do here is model the tracks.json data. Now we're going to look at the fields here and we're going to create a Pydantic model from these fields. You can see there's an ID field, we have a title, an artist, a duration and a last play field. So let's create a Pydantic model in the models.py file to represent these fields. Now what we're going to do is we're going to start by importing from Pydantic the base model class. Now your Pydantic models extend this class, so what we're going to do is we're going to write a new class and we're going to call this schema track, and it's going to inherit from the base model. Now within the class we're going to write fields such as ID, which each have a type associated with them. In the case of ID we want this to be an integer. That's because in our tracks.json file here you can see that we have an ID field. It's actually a string within the data, but when we write these schemas in Pydantic it's going to map that to a number, and that's because we've defined this as an integer. The second field is title, it's going to be a string, and the third field is the artist, which is also going to be in this case a string. The next field we have is duration, and that's going to be a float data type. And that's because if we look at the duration here, we see we have a string with a number. Some of these numbers actually are fractional numbers, so we're going to specify float for that data type instead of integer. And the final field that we have in our data is this last play field. So we're going to create a field here called last play, and we're going to set that equal to the datetime data type. And we're going to have to import from the datetime module in Python's standard library the datetime object. So this Pydantic class represents the schema of our data. We're going to make one small amendment though, and I'm going to import from the typing module the optional class. And the reason we're going to use optional here is because when we create a new track using a post request later in the video, we want the ID to be optional. We don't want the user to send that ID to the server. We want to auto generate that. So we're going to make this an optional integer with a default of none. And I think this will make a bit more sense later in the video. So we can save that file and we're going to head over to the main.py file and we're going to start building a FastAPI application. Now what I'm going to do to start with is paste some imports here. So we're going to import the JSON module, the pathlib module. We're going to import list and union from the typing module. And then from FastAPI itself, we're importing the FastAPI object as well as the response object. Finally, we'll import the track schema that we created here in the models.py file. It's this class here. Now that we have that, let's go back to main.py and we're going to create an application object. We're just going to call it app. And to create that, we simply instantiate the FastAPI object that we've imported here on line 5. Now what we want to do in this video is simply load the data from tracks.json into memory. And we're going to do this using a FastAPI startup event. We'll find more information on that on this page here. And this basically says that FastAPI allows you to define event handlers, which are simply Python functions that you can execute before or after your application starts and stops. So what we want to do is grab the code from here. We're going to create a startup event. So we're going to decorate a function with this line here, app.onEvent startup. And what we're going to do within this function is load up the tracks.json data. So I'm going to set a variable called data path, and we're going to set that equal to a pathlib.path object. And the pathlib.path object will reference by default the current directory if we don't place any parameters in here. We're going to reference that, and we're going to go to the data directory and the tracks.json file. This sets up a path to our file that we want to load in, and then we can open that file using the with open statement, pass the data path to that, and we open it in read mode, and we'll reference that file as f. Once we have that, we can use the json.load function to load that into an object called tracks, and that will take the JSON data and convert it all to Python dictionaries. Once we have that, we can iterate over each track in the list of dictionaries that we get back there. And what we're going to do is we're going to set an empty list here called data and append each track to that data. So we're going to say data.append, and what we're going to do here is we're going to create a track object, which remember is the model, the Pydantic model, and we're going to destructure the track data for the track that we're iterating over to that track model there. And once we've done that, we can convert the Pydantic model to a normal Python dictionary with the .dict function. So the end result here, if I print the data to the terminal here, which remember this is the name of the container, if we run the application, which we can do with the 𝗬𝗍 main app command, we should see that the data is now printed out to the terminal. So basically this startup event, it runs once at the start when you run the server, and it will create a container for all of the data. And now we're going to create a CRUD API for that data, and we're going to start by creating a get endpoint for all of the tracks. Now to create a get endpoint in FastAPI, we use the app.get decorator, and we're going to specify a root called tracks here. And this can take a second parameter which determines the structure of the response, and we pass a response model here, and we're going to set that equal to a list of track objects. So that's why we imported the list from the typing module, and what we're returning from this endpoint is a list of all of the track objects in our data. So this will tell FastAPI what fields we're expecting in the response based on the schema that we created here. And some of those can be optional, which means that it might not be there, and if it's not there, it won't throw an error. So once we have the decorator, we can write the function, and it's going to be called tracks. And that function doesn't take any parameters. All we need to do in this case to get all of the tracks is return the data list. The list here on line 11 is populated in the startup event. It's a list of dictionaries. We return data, and this response model will validate that data, and we can test that out now in the application. So it's the tracks endpoint. If we go to the browser and look at that, we see that we get all the data back as a list of JSON data, and each record contains the fields that we specified in the Pydantic model. So that's how we can retrieve all of the data. Let's now look at how to get an individual record, and we're going to get this record by its ID. So what we're going to do is go back to VS Code. I'm going to copy this endpoint here, and we'll paste it below. We'll change the name of the function to track because we're getting a single track now. And because we're getting a track by its ID, we're going to add a dynamic path parameter here called track ID, and that will then be passed to the function as a parameter. So the function itself will get a track ID as a parameter, and it's going to be an integer. And in a second, we're going to change the response model as well. But let's start writing this function now. So here's a comment that explains what we're going to do. We're going to find the track with the given ID, or we're going to return none if that does not exist. So let's start by setting track to none, and then we're going to iterate over each track in our data. Remember the list of data that we've loaded into memory. So for T in data, and remember T is a dictionary containing those fields, so we're going to check if T ID is equal to the track ID that we're getting as a parameter, and if so, we're going to set the track equal to T. That means we've found the track, and we can also break out of the for loop. Down below here, we're going to check if the track is none, in which case what we're going to do is we're going to return a 404 not found. So to do that, we also need to inject the response object from FastAPI, which we've imported up here. We need to inject that into our function as another parameter here. So we're going to call this response, and we're going to set it equal to the response that we've imported. So now we have access to this, and we can modify our response as we need to. So what I'm going to do is set the status code equal to 404 because we've not found the particular track, and then we're going to return a simple string saying track not found. Now in the case that we have found the track, we can simply return that track object that we found in this for loop, and what we need to do finally in this function is modify the response model so that it returns the correct data type. Currently it returns a list of tracks, or it says that we should be returning a list of tracks. What we're actually returning is a track object, a single track, or a string if that was not found. Now you'll notice above that we imported the union object from the typing module. We're going to return a union here, and to that will pass the types that we could return. First of all, it could be a track object. Secondly, we might return a string in the case of a 404 not found. So the union says we might return one of these two data types. The track model is of course the Pydantic model, which we return if we find a track with that ID, and if we find nothing, we simply return a string here. So we can now test this endpoint out. Make sure you stop the 𝗰𝗽𝗀𝗁 server, and what you can do is use this command here, 𝗰𝗽𝗀 main:\app, and if you specify the reload flag, that will automatically reload the server whenever you make any changes. So you can run that like this, and then we can go back to our page, and if you search for a track with the ID of 1, you see that it returns that data. It returns the correct track with that ID, and if we put 5 in here, we get back the track for that ID too. So what we're doing is we're searching for an ID in our tracks.json data. We compare the ID to what's passed as a parameter. If we don't find anything, we're going to return this string, otherwise we return the track. So let's see if it works with an ID that doesn't exist, such as that one, and we get back a simple string, track not found. And go to VS Code, you see that the status code is 404. So we can now get an object by its ID. What we're now going to do is allow users to create new objects with post request. To create a post request in FastAPI, we're going to use another decorator, and the decorator is the app.post decorator. And again, we're going to send this to a tracks endpoint, and we're going to specify a response model of track. So if we're able to create a track, we're going to return that same track that we've created to the user. And finally, we can also specify the status code in this decorator, and we're going to say 201 for that. So when an object is created, we return a 201 created code, and now we can write the function, the Python function for this endpoint. So we'll call the function create track, and this will take one parameter, and that's going to be a track object that we're passing from the client to the server, and this should have the same schema that's outlined in the models.py file. So we might have an ID, but in this case users won't send IDs. We also have title, artist, duration, and last play. So the function expects JSON data to be sent in that schema, and that's because we've specified this parameter. Now in the post endpoint, what we're going to do is create a dictionary from this track object that's been passed. After validation, that will just take the Pydantic model and create a dictionary with the same fields. Now because the ID is optional, what we're also going to do is assign an ID to this new object. So we can access the ID field, so we use the dictionary syntax for that. And we're going to use a lambda function here to get the last maximum ID, and we're going to add 1 to that and assign that as the new ID. So we use the max built in Python. We pass our data, which remember is the dictionary containing all of the tracks, and then we can pass a lambda function to that. So from the existing data, we want to get the ID, and this statement here will give us back the maximum ID in our data set. So what we then need to do is take that, get the ID from that dictionary, and we can add 1 to that. So this looks a little bit complicated, but basically we have this max component here. That gives us the record with the maximum ID in the data. We then get that record and we access its ID and add 1 to it. That's all that that's doing, and it gives us a new ID which we can assign to our new data. Now normally at this stage you would add this new object to your database. Because we are currently working with just a list that's in memory, we can simply append the new track to that list. So we're appending the track dictionary to the in-memory data structure, and then we can simply return that same track dictionary. So we now need to test this post endpoint. So to do that, I'm just going to use a curl command. Curl is a built-in terminal tool on Macs and Linux that you can use to send HTTP requests to servers. So what we're going to do in this terminal here, I'm going to paste a command in that is going to hopefully send a post request to our application and hopefully add the new record to our in-memory data. So let's go over the command here. Curl, we specify a method of post and a content type of application JSON. The data with the -d parameter that we're sending contains the schema that we're expecting. It has an artist, a title, the last play, and a duration field. And the final parameter is where we're sending this post request to, and it's localhost and the /tracks endpoint. And remember the slash at the end of this URL here. And when we execute this, we get back an internal server error. So let's go to VS Code. And the problem here is that when we use the max function, the lambda should be passed with a key argument. When we do that and go back to the terminal, if we re-execute this, we get back the object that's been created. And that's because we're returning this track instance here, the dictionary containing the new data, and the response should have that structure as is determined by the response model parameter. And you can see the status code below, 201 created. So that should have added that to our in-memory object. And if we go back to the list view here, which is remember /tracks, we send a GET request to that. The new track should have the maximum ID in the data, so it should be at the bottom, and you see it here in the data. It takes the last maximum, 7724, and it gives it a new ID of that ID plus 1. So that covers a post request. That's how you create new information. And what we're going to do now is a put request. We're going to modify an existing record. So let's go back to VS Code, and what we're going to do is copy this function here. This is the one that gets a track by its ID, and we're going to paste that below, and this is one we're going to modify slightly. It's going to look for a track by its ID because it's going to modify that particular track. Now the signature for the decorator will change slightly. It's going to be app.put, and that's because we're doing a put request here. But other than that, this will remain the same. We're searching for a track with this ID, and the response will be the newly updated track, or a string that says that the track could not be found. Now when you send a put request, you also send the new data that you want to put in the resource. So what we're going to do is we have a track ID, which is going to determine what we're changing, but we also need the newly updated data as well. So let's pass a parameter called updated track here. And the schema that the server should expect here will be that of the track model. So this updated track is what we want to actually set our data to. And when we find a track with a given ID, we want to update the records with the new data. So this part of the code here will remain the same. We're going to search for a track with the ID that's passed in the URL. And if that track is not found, we're going to return a 404 and a string saying track not found. If the track is found, what we're going to do is we're going to iterate over the keys and values in our updated track. So we're going to say for key and value in updated track, and remember that's a Pydantic model, so we're going to convert it to a dictionary, and then once it's a dictionary we can use the .items function. And all Pydantic model objects have this .dict function that will take the model and convert it to a dictionary. So we're looping over each of those. Now we don't want to change the ID, so we're going to check if the key is not equal to ID, and only then are we going to change this particular field. So if the key is not equal to ID, we're going to index into the original track at that key, and then we're going to change that to the value of the updated track. So for example, if we look at the models, we have a title field. If we go back to main.py, what we're going to do is take the updated track that's been sent to the server, and we're going to set the title field to whatever the new value is, and it might not have changed, but in this case we're just going to reset the value anyway of the original track object, and that modifies the in-memory data structure, and we can then return the new track with its fields updated as they have been on line 62. So what this means here is that for all fields except ID, we're going to update those fields to match what's been passed to the server from the client, and that's the JSON in the updated track, which we receive here as a parameter. So now that we've written that function, we're going to test it out. If we go back to our API, we can see we have here the object with track ID 1. We're going to change the title, the artist, and the other fields here using a put request. If we go back to the terminal where we were previously doing the post requests, I'm going to paste a command in here. This is a put request. The -x put will specify that in a curl command, and you can see the data that we're sending is totally different than it was before. We're updating the artist, the title, and the other fields, and in the URL we specify at the end here the ID of 1, so that should update that particular ID. Now if we execute this command, we get back an object, and that's the newly updated object. We can verify that that's worked by going back to the browser here. You can see currently the field names here and the values. If we refresh this page, we should see that it's been updated with the new values. So that's working fine. That's how you write a put request in FastAPI. And what we're now going to do is copy this function for the put request, and we're going to modify it very slightly to create what's called a delete request. A delete request is another HTTP verb that you use when you're wanting to delete a resource from the server. So what we need to do is modify the decorator slightly. It's going to be app.delete to specify a delete request, and a delete request, we don't need any response model here, so I'm going to get rid of that field here. So in this case the decorator only takes the path as a parameter. And we can also get rid of the updated track. We are not sending any JSON to the server, so we don't need any validation of the schema. What we do need is the track ID that we're actually going to delete, and we also need access to the response object. Now, because we've got a list of dictionaries, what we want to do here when we're actually trying to find the track, we want to find the index of the track that we want to delete. So we're going to modify this slightly, and we're going to get the index as well as the record, and we're going to use the enumerate function in order to do that. This is built into Python, and we can use that to get the index as well as the object. And if the track ID matches the ID that we've sent to the server here, then what we're going to do is we're going to store that in a track index variable, which will by default set to none, and we'll update line 71 and set the track index equal to the index that we found that record in. So instead of finding an object, what we're actually doing is finding the index of the object. We can then check if the track index is none, and in that case we can return the 404 not found. Otherwise, we can actually get rid of this code here, and we're going to delete the track from the list. And to delete an item from a particular index, we can use this syntax here. So it's the data list, and we're deleting the item at the index that we've found. Once we've done that, we can simply return a response with a status code of 200, indicating that that's been successful. Now again, we're working in memory here with this data. In a future video, we're going to use 𝗤𝗵𝗽𝗀 and do this with the database. But for now, let's test out the delete request. If we go back to this terminal here, we can clear out the previous code, and we're going to delete the item with the ID of 1. So the request for that's very simple. We say curl-x delete, and we put in the URL the ID of 1. We execute this, we get back nothing. But what you'll notice if we go back to the browser and refresh, we see that the list no longer contains an item with ID 1. So this endpoint, this delete endpoint, has successfully deleted that from the data. So that's all for this video. We've successfully created a CRUD API with FastAPI, and we've got a delete endpoint, we've got a put and a post endpoint for changing and creating data, and we have two get endpoints. One simply returns all of the tracks, and the other will return a track by its ID. And in all of the endpoints that are searching for a specific item, such as this one, we pass the track ID in the URL, and that's then accepted by FastAPI as a parameter to the function. So that's all. In the next video, we're going to use 𝗤𝗵𝗽𝗀, and we're going to create a proper relational database rather than doing this in memory. So thank you for watching. If you've enjoyed the video, please like and subscribe to the channel, and we'll see you in the next video.